Yeah, okay, I have here the formula sheet open. You can all see that. Yeah, chapter 7, only 2 chapters, and hopefully you should be able to do it all correctly. Tomorrow is our exam, midterm 2. So we started with the current, right? We define what current is. So that is the rate of flow of charges, delta Q divided by delta T. So, we can have a question where, you based on this, maybe charges and the time is given, you'll be asked to find the current, or maybe other way around, maybe current and the time is given, asked to find the charge, and so on. Okay, right. Then we have the connection between current and the drift speed. Say in a wire, metallic wire, the charge carriers are electrons, the negative charges, which is flowing. But it is not that you have to wait till the electrons to go through the circuit and come back to the source, the EMF. Okay, that will take quite a long time. But the moment you close the switch, you see the bulb lighting up. You know the reason, right? Because you don't have to wait the charge that is coming out of the battery to make complete journey. The moment you turn the switch on, every free electron in the wire will feel the presence of the electric field. So it is the electric field which travels at the speed of light. The drift speed, the electron or the charge carrier speed, which is the drift speed, is related to the current through this equation. That's the next formula that you have, the concept you learn. And you should know what the meaning of each and every term here. The formula sheet doesn't give the definition. I mean, what each term means. So you should know what they stand for, okay? Right. Are you all with me?
Yes, Doctor.
Okay. Then we introduce the Ohm's law, define the resistance. I mean, it's also called the law, although actually it's the definition of the resistance. If we have a resistor and there is a potential difference of delta V across this resistor, and if the current flowing through is I, then the resistance is given by that equation. That is the Ohm's law. For certain elements or devices, this R is a constant. Then we can say it's a law. Okay, but it's not actually a law. Anyway, the name stays. Then we introduce resistivity. Okay, resistivity is a property of the material. Okay, resistance, you can take a piece of copper wire, and depending on its length and the cross-sectional area of the wire, the resistance will change. But the resistivity is a constant for a given material. So this is the connection between the resistance and the resistivity. Okay, right. Then we have the variation of the temperature variation of the resistivity and resistance is linear, and the coefficient, the constant here, alpha, is called the coefficient of resistivity, temperature coefficient of resistivity, okay, alpha. So you might have a question based on that. You may be given the value of the resistance at a certain temperature and asked to find the resistance at another temperature, given the temperature coefficient of resistivity. Then you have the power. Yeah, sure. This one? This is resistivity. This is resistance. It will be written in the question. It will be given in the question, right? The question will say, if it is resistance, it will label it as resistance, okay? If it is resistivity, it will say it is resistivity. So they are different, okay? Then we have the power and the energy. What is power? Power is how fast the energy is being given, okay, transferred. So we get this when a current is flowing through, there is energy that is being circulated, the electric energy. The power is given by power through, say, a resistor will be the potential difference across that resistance multiplied by the current. Okay, the power is I into delta V. We can also, by making use of the Ohm's law, I can give the power also as this expression or that expression. It's a matter of eliminating, say, the current from the first expression, you will get without the current. Here, this is without the voltage. Depending on the question, you may be using one of these three expressions for the power. And then we introduce another unit for measuring energy. Joule is actually very small unit. So that's why I introduce this. 1 joule is actually 1 watt second, right? So instead of watt, we got the kilowatt. Instead of second, we have the hour. So this is also a unit for energy. And you can see it is a very big value. So 3.6 million joule is 1 kilowatt hour. So that is basically, that's it in chapter 17. Okay, if you understand all these equations and what they stand for, you should be able to answer the question. Also, the certain concepts, in statement question. Just go through past midterm that I have posted. Most of the question, almost repeat. Okay, sometimes exact repeat, sometimes, change the numbers, sometimes small twist. Right. Then we got this chapter 18. So we are talking about terminal voltage of the battery. So, that is, if you have a battery, a real battery, and say connected to a external load resistance, this real battery will have its own resistance inside. Okay, ideal battery, there is zero resistance, but in real battery will have a small resistance inside. So I can put it like this. EMF of the battery plus a small resistance R. So what appears outside is, which we call the terminal voltage, it is equal to E minus, that is the EMF of the battery, minus whatever the drop inside the battery. Then we talked about combination of resistance, like we had for the capacitors in previous chapter. We also can have combination of resistors in series. It actually the inverse of what we had for. So when it is in series, you add them. Inverse addition, right? You add the inverses, then take the inverse of the whole thing. Very good. So you should know how to use your calculator to get that. Then we have, when the circuit become a little bit more complex with many loops, then Ohm's law and reducing to one resistor sometimes become difficult. So that's where you need to use the Kirchhoff rule. The Kirchhoff rule number 1 is the junction rule. And the number 2 is the loop rule. So the junction rule is, you say, current coming into a junction, the sum of all the current coming into the junction is equal to the current going out of the junction. And the loop rule is, you start from, you take a circuit, a loop, and start from one point and go through a circle and come back to the same point. Then you say, while you do that, you add all the potential changes. The sum of that is equal to 0. This is conservation of energy. Junction rule is conservation of charge. Then finally, we have the RC circuit. That is where we have a resistor and a capacitor in series connected to a battery, a simple RC circuit. Then we have some equations there. When you close the switch, it get charging, the capacitor gets charged. The rate, how it charges is given by this equation. Charge will gradually increase and come to the maximum value. The maximum value is CE, is the voltage of the battery. So a similar relationship for the voltage, how the voltage develops in the, so it's an exponential increase. But while discharging, we have, we should look at the difference. 1 minus E, here there is no 1 minus. So here what happened? It is drops, it's exponential decrease, okay? So there'll be question based on that. Also, we have something called the time constant, which is R into C, okay? Time constant is a value when it is charging after one time constant, because RC has a unit of time. Okay, second, if you put R in ohms and C in Farad. 3.2. So the charge will become 0.632 times its maximum charge after one time constant. Okay, one time constant is for different circuit. It will be different time constant, right? Depending on what your R and what your C is. Very good. Okay. Right. Then, yeah, discharging, it's similar, but it is exponential decrease, not increase. So you should look at the 1 minus, and there is no 1. It's just e to the power minus t over tau. That's about it. So now I have chosen some questions. I'm going to the oldest I have posted, 2016 or 17 spring. Question 21. What comes after that is not included because this is the RC circuit. Okay, so let's look at this question. The circuit contains 6-volt battery, 4-ohm resistor, and 0.6 microfarad uncharged capacitor, an ammeter, and an open switch, all in series. How long would it take for the charge on the capacitor to reach 63% of its maximum value once the circuit is closed? Okay, right. So when you look at this, you should remember this. It is 63.6032 is the amount of charge it will reach after one time constant. So you know the answer quickly after one time constant. It is actually 63.2, but it's okay, 63%, 63.2. Okay, anyway, it is 0.632, so on. Okay, it's 1 over E. E is that Euler's number. Okay, anyway, so now it is an easy question because you have the value of R, you have the value of C, but you must remember, yeah, minus 6. Now, again, let me remind you, you should know what is micro. Tell me, minus 6. Yeah, we are not going to tell you this, okay? You should memorize them. So, next, milli. Millimeter, how many Yeah, 3. You said 2? Oh, 3. Okay, sorry. All right. I will replay and see whether you said 2 or 3. Right. Okay. I heard you said 2. No. But you meant 3. Okay, fine. Then you changed. No problem. Okay. Now when you go up, kilo. 10 to the power what? Kilo means what? Come on, 1 kilogram is how many gram?
3, yeah, right?
So kilo means 1,000. Okay. Right. Kilo. Then mega.
Isn't it 6?
6, yeah. So you should memorize this, okay? Mega is 6, micro is minus 6, mega is plus 6. Then giga.
Giga is 9.
Yeah, that's right. Yeah. Thank you. Right. Okay. So these things you should know, okay? Because I'm not going to tell you this. This is your support, your engineers, okay? You should know, memorize it. It should be part of internalize it. Right. So this is an easy one. So actually, you can kind of, it's just recognize, but you can even use the equation to get the answer. Say, how long would it charge? You see, Q is equal to Q0, that is the maximum charge, 1 minus e to the power minus t over tau. Okay, so Q to become 0.63 times Q0. I mean, you don't really have to do this because you know the shortcut. Okay, then cancel. Then you put for tau r into c, then solve for the time. No, sorry, what are we? Yeah, we find this time, right? How long? And, but there is no need to do that because you know quickly it is r, it is one time constant. Because from here, this will become exactly 0.63. Yeah, never mind. Okay, there is no need to go through all the trouble. we know quickly it is one time constant, then we can get the answer. Right, let me go to question number 20. The circuit contains 6-volt battery, 4-ohm resistor, and 0.6 microfarad capacitor, an ammeter, and a switch all in series. What will be the current reading immediately after the switch is closed? It's about charging, right? The capacitor is not charged. You close the switch. Let me ask you, how much charge immediately after? There's no charge, so it will start from 0, right? The charge will be 0. But the question is not about charge, current, which we did not talk about. It is not in the formula sheet, okay? So pay attention now. The current will be maximum because it is as if there is 0 resistance here because the capacitor is not opposing the motion of the charges. So the current will be the maximum current. So it will be simply the EMF divided by the resistance. So it is 1 point. So the moment you close the switch, the charge will be 0 on the capacitor plate. The voltage on the capacitor plate will be 0 again, right? But the question is, what is the current? Current will be maximum because as if this capacitor is not there, it is not opposing, right? It is not giving any resistance. So just imagine it's not there, the current will be 6 divided by 4, 1.5 amperes. So suppose I extend this question, I also ask, and the voltage on the capacitor plate. What's the answer? I just told you 0, okay? Right, Jude?
Doctor.
Got it? Okay. Right. Fine. While discharging, you know, it will be other way around. The charge and the voltage, charge will start from maximum, it will reduce, okay? The voltage will also start from maximum and reduce. The current will be also, it will be start from maximum and reduce. Okay, now this next question, 19, right? See, most of the question you see there is a pattern to my question, right? So, you know, I don't want to, you know, I want to see that you have learned something, okay? So just you should be able to get full score, inshallah, okay? There may be one question, maybe, you know, a bit challenging, but most of the questions are just easy and you have seen before. In the circuit segment shown, 2 milliampere I current and showing the direction and charge on the capacitor 25 microcoulomb. What is the potential difference? Where VA minus VB. So you should pay attention to what is the difference is asking. Delta V. So F final is the point A, initial is the point B. So that is first thing.
So we start from point B, right? We start from point B, right?
Yeah. Because the question is to asking VA minus VB. That means A is the final, B is the initial. So you have to start from point A, which is the initial, point B, which is the initial, and go to A, which is the final. So suppose I can switch the question. I may ask you, what is VB minus VA? Then you should know what to do. You have to start from the other way around, okay? So
we'll start from A.
A, if I did like that. So you have to read the question carefully and make sure what you are asking. Here he is asking VA minus VB. That means the potential difference delta V when you go from B to A. Right, so this is how you need to go from B to A. Now, so it will be this potential difference, let me call it, I'll segment into 3 parts, and this potential. So that will be delta V1 plus delta V2 plus delta V3. Delta V1, let me discuss that. So you are going to the left, okay, and you are going with the current. Current, you know, flows from high potential to low potential. Okay, remember that from Ohm's law, you know the potential change is this IR, but I didn't put the sign. Now you have to decide the sign. You know there is a potential change, but is it going to be decreasing or increasing? So how do I figure it out? Look at the direction of the current. You know current flows from high to low. So current is flowing in the same direction as you are moving. So therefore,
it's negative. It's a
yeah,
decrease. It's negative.
yeah. So it is negative, right? Because fine. So minus. Then delta V2. So you know the definition of the capacitance. It is Q over delta V. So delta V will be Q over C. So you can say it is Q over C. Q is given, C is given. Now whether it is plus or minus.
It's plus because it's going from low potential to high potential.
Okay, Jules is telling it is plus because you're going from minus of the capacitor place to the positive. So negative side is lower potential, positive side is higher potential. So it is plus. Very good. Then you have a 15 volt. So you just write the 15 first. Is it plus or minus? You know the
It's
big,
minus. Yeah, because the big sign is positive. So it's going from positive to negative. So high potential to low potential. Therefore, it's minus.
Okay. So it is, you're going from the positive end to the negative end. So it is minus. Okay, now you substitute the values. I is given, make sure about the unit, okay? Very important, you pay attention to the unit. Q is not SI unit, it is not Coulomb, it is micro Coulomb. So you should know what micro stand for and so on. So you can follow the solution. So let me go to the next. There's a question, Abdulaziz. If it was VB minus VA, yes, exactly. Yes, Abdulaziz, correct, you're right. Yeah, because everything will be reversed, right? So you will have plus 15 and minus 50 and plus 30, which will add to minus 5. Very good. Okay. Right, so we go into this question. What is the current flowing through the resistor R if R is equal to 2 ohms and E1 is equal to 10 volt? So here we have a little bit complex circuit because not just one loop, two loops. And this E1 is given to us. E2 is not given. R is given to us. And he's asking what is the current through this R. Okay, so that is a question. So now it's a bit of complex circuit in the sense, you know, it has two loops, and maybe you better go for, I mean, you cannot reduce things, and there are two batteries and so on, not just one battery, and one battery we don't know. We should use the Kirchhoff junction loop rule. So let me call it point A here, point A, B here, point C here, point D here. So I'm going to take the loop, this A, we go from A to B to C to D and back to A. So this is a loop. So this is loop. I'm going to move in that direction and going to apply the loop rule. What is the loop rule? I collect all the potential changes and say the sum of those potential changes is equal to 0. So when I go from A to B, there is E1. And E1 is given. That's why I choose that loop. Suppose I choose this loop, I'm going to have another unknown. I'm not interested in the E2. I'm only interested in finding the I. So I avoid that loop. So that's why I choose the top upper loop. Right. Then you have this resistance, and you are flowing in the same direction as the current. So it will be IR equal to 0, no more. That's it. You solve for this. This is given. This is given. This is the only unknown. Just solve it. Okay, easy. So let's move on. So this here, there is no numbers. You are just asked to write the expression for the loop rule for the lower circuit. So, well, if I can, you know, lower, it's shown the lower circuit. It says lower loop of the circuit. So it is like if I put some number BA C, D. So I'm going to take the loop from B to A to C to D and back to B, B, A, C, D, B. So let me start from B. When I cross the E, you're going from negative to the positive. So it will be E1 plus. Then through R1, you're moving in the same direction as the current.
It will be minus I2 R2.
I1, right? Isn't it I1?
I1, sorry, I read it wrong.
I1.
Read it wrong.
Okay, R1. Then you're going through R2. But when you are going through R2, you are going to the left, but the current is flowing to the right. So you know the current flows from higher potential to lower potential. So that means you are moving from lower potential to higher potential. That's why it will be plus I2 R2. Then you're going crossing the battery from positive to negative. So it is minus E2. So I think the C is the correct answer, right? Okay. To R3. Yeah. Is it 3? Oh, I'm sorry. I'm looking at this loop.
It's lower loop.
Lower loop. Sorry, guys. Sorry. Okay, let me lower loop. Okay, lower loop. So fine. So you are starting from B. Okay, B, A, C, D plus E2, then minus I2 R2. I'm sorry, Jude. Okay, are you okay now? Are you okay, guys? The quiz is not working. Okay, Sadim.
Yes.
Sadin. Yeah, I did not open the quiz. Okay, I will just, you have to pay attention to me. I will open it when it is ready. When everyone is ready. You have to be in the class now. I'm reviewing. Sadin, are you there? Don't worry about the quiz now. Nobody can start the quiz unless I release it. Okay. All right. Yeah. Yeah. It depends. It depends. Sometimes, okay, it depends on the question. Sometimes we'll say, okay, take this loop. Sometimes you have to decide which loop to take. Okay. So, you know, it can be either way. Right. So you have to choose wisely. So, you know. Right. Yeah, where am I? Yeah, all right. Now the lower loop, right? I2 R2. Then here you are going against it. So it will be plus I3 R3 equal to 0. That is C. Okay, right. Right. So number 16, we have this circuit, and the current I1 is given, I2 is given. You are asked to find what is I3. So, you know, this is an example for applying the junction rule. So you can either choose this junction A or the B, doesn't matter, it will give the same answer. So it's very easy. You go to the junction A, stand there, and you'll say all the current coming into the junction, sum of all the current is equal to sum of all the current going out of the junction. So when you stand there, so this is sigma I into the junction, sigma I out of the junction. All the currents are coming in. I1 is coming in, I2 is coming in, I3 is coming in. So for this, you'll get I1 plus I2 plus I3 and nothing going out, so 0. So you just substitute for I1 and I2, then you get I3. This is 5. Okay, I don't know why I put 6. Okay, 5. Minus 2 minus 3 is 5. So we see that we have 5 amperes, but see what happened. You get a negative value, right? He says I3 is supposed to be a magnitude because we are saying all the current coming in, the magnitude of the current that are coming in is equal to plus sum of all the magnitude current going out. So why did he get a negative sign? Because my assumption is wrong. we said the current is coming in, I3 is coming in. So since magnitude is correct, it is 5 amperes. So since I got a negative answer, it only tells you it is going out. Okay, so you decide, you know now the correct situation. So that means the current will be through the out, okay, it is going out. So through the R3, it will be going to the left. So this is 5 amperes, this is also 5 amperes. So which one do you choose? To the left. So, okay. That's why it will be going out from the junction. Okay, right. Unless you ask me a question, I am going to stop now. I'm going to release the quiz. Shall I do the quiz now? Any question? Any particular question?
Doctor, can you do question 7 from past paper 2016? Like the one you just did, there's question 7. Can you do it, please?
Sure. Jude wants me to do question number 7. Let me do it. 2 wires of the same with the same resistance have the same diameter but different length. If wire 1, let me take it and let me copy and paste in the, we call this snip sketch. Okay, so here we are. 2 wires having the same diameter. Okay, D1 equal to D2, but different length. So L1, L2. Wire L1 and wire length L2. How do L1 and L2 compare if wire 1 is made of metal with resistivity, say ρ1, and wire 2 resistivity ρ2? So it's just simply, you know it is going to be this equation, right? You start with this. You write the expression for the resistance and resistivity for wire number 1 and wire number 2. So wire number 1, you will say R1 equal to ρ1 L1 over. You don't make any assumption now. You write everything is different. Then you read the question again to see what are the same. So same resistance. That means R1 is equal to R2. Same diameter. Okay, now let's postpone that. Okay, yeah. Resistivity is given. The value of resistivity is given. So since we are going to compare the lengths of this, maybe we can divide by call this equation number 1 and call this number 2 by dividing one by the other. So let me divide 2 by 1. So it will be R2 over R1 equal to ρ2 L2 divided by A2 divide by this. But division, you can make it as multiplication if you switch the up and down. So it will be A1 divided by ρ1 L1. Now I can work on this and substitute what is given. This is same. R1 is equal to R2. It's given, said in the question. So this is equal to 1. And ρ2 and value of ρ1 are given to us. So I will substitute at the end. And what we are asked to find is this ratio L2 over L1. And we got A1 over A2. Okay. Now, area is not given the comparison between the area. What is given is the diameter. The diameter is the same. Is it the same? Same diameter. Diameter is the same. If the diameter is the same, cross-sectional area is all the same. Because area is given by pi r square. That means pi d over 2 square. That means pi d square over 4. If d is the same, that means a1 is equal to a2. This is also 1. Okay. So now you have 1 equals to rho 2 over rho 1 multiplied by L2 over L1. So L2 over L1 is equal to rho 1 over rho 2. Substitute for rho 1 and rho 2, you get the answer. Okay, the values of rho 1 is given, rho 2 is given. Jude? Jude, where are you? Did you ask this question? What happened? Everybody's quiet. Jude, where are you? Did I lose them? Okay, anyway, I don't know what happened to her. She asked me this question. She's quiet. Right, so let's start the quiz.
Sorry, doctor, it froze.
Okay, okay.
I just froze and the internet left. I'm really sorry.
No problem. Okay, anyway, I'm recording it. You can look at it. Okay, let's start the quiz. So let me editing. Yeah, everybody get ready. Okay, I'm going to release the quiz. Timing. You need just 20 minutes. Okay. 11:50. What's the time now? 11:40. Okay, that's more than enough. 15 minutes. You'll have only 15 minutes from the time you start. Okay. And what else? Okay, save. And I will show it now. Refresh your page. Okay, start the quiz, please. Now I'm giving you another chance because most of the people didn't get it right. I can just brief you quickly. The first question is what you've got wrong, many of you. So suppose you have two charges, Q1 and Q2, and what is the potential at some point in between, the point P, what is the potential? So there'll be a potential from this and the potential from that, you add the two potential, that is how you do it. But what is the equation? It is K Q1 R1 plus K Q2 R2. You should substitute Q1 and Q2 with the sign, and you have to take care of the units. And the value of K is 8.99 and the power 9. And this is R1 and this is R2. Okay, right, start.
But doctor, can we factor out K? Can it be K times Q1 over R1 plus Q2 over R2?
Yeah. You mean this?
Yeah. Thank you.
Okay. You did it? Sorry, Gale? Oh, yeah, fine. You can do anything. Okay. It's not an exam quiz. Not got it. Start. Okay. Right. Once you do it, you can log out and leave. Okay. So I'm going to end the session. If you have any question, ask me now. There is Shahad is asking. Yeah, the quiz is for everyone, okay? Because the previous I reset everything because you did not, this is for everyone. Everyone has to do it, okay? Most of you got 0. Maybe question number 2, you got, many of you got it right. Question number 1, most of you got it wrong. So please, it's for everyone. Some of you got correct, you know, I have a record of who got it correct, but I want everyone to do it, please. This is the question number 1. Q1 divided by R1, Q2. It's the same thing because I took the K out. It's the same thing. You just do whatever way you like, okay? Yeah, it's the same, okay? Just simple algebra. Please make sure you put the correct unit, okay? The conversion and all. Yeah, I'm going to end the session for the online people. When you finish, you can leave, okay? You can log out now and do the quiz.